Hey guys, hope you guys are doing well. This is going to be what you're going to be taking notes on Friday in class. This is for Honors Precalculus. It's our last lesson in Lesson 7 or in Unit 7. Next week, what you guys are planning on doing is doing the practice problems for this section and the study guide for the quiz. We're probably going to be taking the quiz next Thursday, and then on Friday we'll have something fun to do, and then we're going to move on to calculus. So we're about probably, 2 weeks ahead of where I was at last year. We're doing pretty good, and we're planning on finishing the first 3 units of calculus. So we're going to be right where we need to be. Today, what we're going to be doing is we're going to be doing something called partial fraction decomposition. In the past, in Algebra 2, you were able to combine two fractions like such. You notice that this had x minus 4. You notice this had x plus 2. And what you did is you multiplied each of these by the opposite denominator. So we multiplied this by x plus 2 over x plus 2. And we multiplied this by x minus 4 over x minus 4. When you do that, you're able to combine these into one fraction with one denominator. And so there's some benefits to this. In this section, what we're going to be doing is we're going to be going the opposite way. We're going to be going, instead of from left to right, we're going to go from right to left, and we're going to get all the way back to this original function. But before that, we're going to need to be able to solve a system, and that's why we did 7-1 and 7-2. When you guys get to calculus, if you're in BC calculus, you will be needing to know partial fraction decomposition when we're doing integrals. So you'll be learning this in Unit 5 of BC calculus, maybe a little bit further along in that section, and then that's going to be about it. So what we're going to do is explain what we're doing. We're going to talk about how to find this, and then we're going to talk just a little bit. If you guys look at this entire thing is called partial fraction decomposition. We're taking each of this entire fraction and we're decomposing it into two different partial fractions. We have one here, and this is called the partial fraction decomposition of this function here. Don't mind my wife. She's playing Harry Potter and she's trying to catch things in the background, and I think she just caught something and yelled yes as loud as she could. It's kind of funny. This is the basic idea. When you guys have a function that's like this, where we have a polynomial over a polynomial, and this polynomial, we have 3 different terms, right? Each of these are unique terms. So we have 1 unique term, 2 unique terms, 3 unique terms. And in each of these, it's going to require us to make a new partial fraction to go along with. The basic idea with this is what we're going to do is we're going to take and multiply every term by all of these denominators. And when we do it, all of these denominators on this side are also going to cancel, and we're going to be left with the system of equations in one variable, but we're going to have 3 different things here that we're going to be solving for, the 3 different variables. Okay? And this is the basic idea for it. When you do it, you're going to have X amount of distinct linear factors. We'll go over a few of this, and then we're going to go if they're not distinct. So this is a part I want you guys to pay attention to. I'm going to try to make it look as nice as I can. I'm going to add another page already just beforehand, just because I know I'm going to go over it. And we're going to go step by step. First off, you guys are going to set up the partial fraction decomposition. Step number 1. We're going to set up the partial fraction decomposition. The bottom is already factored into 2 distinct linear factors. So we're going to write x plus 14 over x minus 4 times x plus 2. And this is equivalent to a over x minus 4 plus b over x plus 2. The order these are in do not matter, but when you solve for A and solve for B, they must go in the correct position. This is where we go into the next part. We're going to multiply by the denominator. We're going to multiply every term by the denominator. of the left-hand side. We're going to multiply each term by the denominator of the left side of the equation. And so we're going to end up doing this thing where we have x minus 4 times x plus 2, x minus 4 times x plus 2, x minus 4 times x plus 2. Once you guys get this, we're going to go through and we're going to cancel all of the things that they have in common with the denominators. So x minus 4 cancels, x plus 2 cancels. We're left with x plus 14 on the left-hand side. On the right-hand side, we're going to be left with x plus 2 times a. And we're going to go ahead and distribute. And we're going to get ax plus 2a. Okay. For the last term here, we're going to cancel out x plus 2, and we're going to go ahead and distribute b. And we're going to get plus bx minus 4b. Okay. Now, here's the part where we're going to group like terms together. You guys are going to notice that certain terms here have the same variable attached. These have x's, and these are going to be technically constants. It's a number times another number. And so in this, we're going to group like terms. And this is going to allow us to set up a system of equations. Specifically, if you look on the left-hand side of the equation, we have a number. Our red's going to match up with our red, and our green is going to match up with our green. Okay, so when we do this, we're going to have x plus 14 equals ax plus bx plus the quantity of 2a minus 4b. When you do this, make sure not to get rid of your negative. If you have a negative on something, don't factor it out unless you factor it out of both terms. What we're also going to do here is we're going to take out our x. We're going to factor out our x, and we're going to have x plus 14 equals a plus b times x plus 2a minus 4b. Okay. And now we're going to go ahead and take a look. This right here is quite literally the coefficient to x. Over here, we also have a coefficient to x, and that coefficient is going to be 1. So we're able to write a plus b is equal to 1. Okay. As for the other set, we're going to have 14, which is our number, is equal to these two things added together, these two numbers added together. 2a minus 4b equals 14. And this is the part where we're going to be able to solve our system. Okay, step 4. We're going to go through and solve our system, or the system. And to do this, we can solve for a, plug in the other equation, or we can multiply the top part by -2 and then add it, which is what I would prefer to do. So we're going to get -2a minus 2b equals -2. 2a minus 4b equals 14. And we're going to add these two things together. Let me go ahead and keep it in purple. Plus, we're going to add them together, and we're going to end up getting these cancel. And we're going to get -6b equals 12. To solve this, we divide both sides by -6, and we get b equals -2. Okay. We found one of our two variables. To find the other, what we do is we take and we substitute it back into one of our equations. So we're going to write a minus 2 equals 1. We took and substituted it back in for b in this equation. And so all we have to do here is add 2 to both sides, and we get a equals 3. And this leads us to our partial fraction decomposition of x plus 14 over x minus 4, x plus 2, equals a, which is positive 3, over x minus 4. And then we're going to get minus 2 over x plus 2. And that is our partial fraction decomposition. Okay? On your assessment, you guys should be looking for an equation where it has you just set up the first portion of it, where you write out this portion in black. And then you're also going to have one where you're going to have to actually go through and do the full partial fraction decomposition. I believe I have it worth 2 or 3 points on the test. It's one of the bigger ones. So I just wanted to make sure you guys know that. What I'd like you guys to do is please press pause and go and complete the checkpoint number 1 down below. All right. When you guys are done with it, we're going to talk about what happens when you have repeated linear factors. If you have repeated linear factors, you're going to write out each and every one of these. For example, if you guys had x plus 2 over x minus 1 squared times x, okay, this is the same factor repeated 2 times. And so when we write this out, we're going to have a over x plus b over x minus 1 to the power of 1. And then we continue to go with this until we reach our number, plus c over x minus 1 squared. Why is this the case? There are 2 of these, okay? And so, once again, on your test, you're just going to have to write something that's like this, and you're going to have to know the difference between having just the 2 unique factors and then having a repeated linear factor. So what we're going to do is go through, and we're going to do all of example 2, and then you guys are going to do checkpoint 2 on your own. This is going to have a system in 3 variable, or 3, we're going to have 3 different things we need to solve for, A, B, and C in this problem. So let's go ahead and set it up. First thing we're going to do is our partial fraction decomposition. We're going to set it up, okay? So let's go ahead and set up the form. Step 1, set up partial fraction notation. Okay, so let's go ahead and do that. We're going to have x minus 18 over x times x minus 3 quantity squared. Well, this is going to have one factor, a over x, plus b over x minus 3, plus bc over x minus 3 squared. Okay. When we do this, we're going to want to multiply through by the denominator. So we're going to multiply by x times x minus 3 squared, x times x minus 3 squared, x times x minus 3 squared, times x minus 3 squared. And in each of these, things are going to start to cancel. Okay, we're going to have our x cancel, we're going to have one of these cancel, we're going to have both of these cancel, and we're going to be left with x minus 18 equals x minus 3 quantity squared times a plus x times x minus 3 times b plus c times x. Okay, this is going to require us to do a tad bit of algebra. Okay, first off, x minus 3 times x minus 3. This is going to give us x squared minus 3x minus 3x, so minus 6x plus 9 times a. Okay. The next part here, we're going to get x times x, which is x squared. X times negative 3 is negative 3x. Then we're going to multiply that by b. So we're going to get x squared minus 3x times b plus cx. Okay. And like I said, this is a little algebra heavy, but it's nothing that you guys can't do. I believe in you guys, and I know that you guys are going to be fine. So what we do is we distribute, and then afterwards we group our like terms. So we're going to get ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. Okay? And this is the part where we have to group our like terms. Step number 2. Group like terms. Okay? What you guys are going to notice is we have some x squareds. We have ax squared. We have bx squared. But over here, we're missing an x squared altogether. So we're going to write 0x squared plus x on that side, okay? So we're going to have 0x squared plus x minus 18 equals ax squared plus bx squared quantity. Okay. The next part we're going to have is we're going to have our x's. So we have negative 6a, negative 3bx, and cx. This is all going to add together to give us just x. So we're going to be left with plus negative 6ax minus 3bx plus cx. And then the nicest part of this is we're going to have 1 that's all by itself right here. We're going to have just 9a is going to give us negative 18, which you guys can already see what's going to happen with that. We're going to have plus 9a, which is all by itself. It's the only constant that we have here. Okay. We're going to go through and we're going to factor out our x squareds. We're going to factor out our x's. And we're going to have 0x squared plus x minus 18 equals a plus b times x squared plus negative 6a minus 3b plus c times x plus 9a. Once again, it's a lot of algebra. None of it's difficult. It's just putting a lot of algebra together. It takes a little bit of getting used to, but once again, you guys have it all together. What we know is this is the coefficient for x squared, and this too is the coefficient for x squared. So we're going to have a plus b equals 0. Okay, the next part we're going to have is we know that this is the coefficient for x. That's obviously going to be the last thing we want to solve for. We're going to have everything here, negative 6a minus 3b plus c equals, and we might want to write this with a place, like having a 0 in that place. We know it's going to be equal to 1 because the coefficient in front of x is just 1. And the last part you guys are going to be pretty happy with, we know that 9a is going to be equal to negative 18. So we're going to have 9a equals negative 18. I'm not even going to write it the proper way. Which one are we going to solve for first? We're going to go through here, and this is where we solve our system. We solve the system. And so what we're going to do is solve for a. We're going to divide both sides by 9. We're going to get a equals negative 2. Okay. From here, we want to plug it into an equation that has 2 variables. So we're going to go through and we're going to substitute it into this equation. We're going to get negative 2 plus b equals 0, which here, this is going to require us to add 2, and we get b equals 2. And then as you guys guessed it, we're going to take both of these and then substitute it back into the second equation for both of these. And we're going to get negative 6 times negative 2 minus 3 times 2 plus c equals 1. And from here, we're going to get 12 minus 6 plus c equals 1. So we're going to get 6 plus c equals 1. And then we subtract 6, and we get c equals negative 5. So when we do this, we're going to get the partial fraction decomposition, x minus 18 over x times x minus 3 quantity squared equals a, which is negative 2 over x, plus 2 over x minus 3, minus 5 over x minus 3 quantity squared. And this is the partial fraction decomposition right here. It was a lot of work, but we went backwards and we factored and pulled apart our fraction. All right, guys. I hope that you guys have a wonderful weekend. Enjoy yourselves. Hopefully this wasn't too much. I know it wasn't too much. You might struggle a little bit, but it's nothing you guys can't handle. Down below, you guys have one last problem, checkpoint number 2. Please go ahead and finish that. Have a beautiful weekend. We'll do the practice problems on Monday, study guide, and a quiz next week. So have a great night. Bye.